Growing up, our parents help shape who we are and what we believe in. The information mom and dad tell us over the years is typically very useful, but that does not mean that they are always right. Eventually, we learn that there are no monsters in the closet, and kissing boo-boos doesn't instantaneously heal them. It is important to take a step back and really think about what is said to you, as these so-called facts can sometimes turn out to be common misconceptions. A common misconception is something that many people believe in that is based on faulty evidence. In the past, people believed the world was flat, but we now know it's round, and that's a fact. Imagine your neighbor Emily has cystic fibrosis, and you ask your mom, how did she get that disease, and why don't I have it?
Oh, sweetie, it's in her genes.
Let's jump into her back pocket and find out about the common misconception, do disease genes run in the family? Let's begin. According to the text Principles of Anatomy and Physiology 2014, there are 100 trillion cells in the body. Within each of these cells is the genetic blueprint for what you are and the traits you have. This DNA is organized into 23 pairs of chromosomes. Every chromosome has a unique set of genes, each of which reflect different traits which makes you, you. Let's separate the pair of chromosomes of chromosome 7. We all have 2 copies of every gene, 1 copy on each chromosome. Genes typically code for proteins. However, sometimes events occur that cause random mutations in a gene, resulting in a dysfunctional protein. We all have a CFTR gene, which is essential to the body. However, your neighbor Emily has mutations in both copies of the CFTR gene, resulting in the disease cystic fibrosis. How did Emily get this disease? Both of her parents seem healthy. However, this is only partially true. In order for Emily to have this disease, both of her parents must carry 1 copy of the mutated CFTR gene. Both of her parents are carriers, 1 healthy gene and 1 unhealthy gene. The healthy gene allows them to produce a functioning protein and thus show no symptoms. When the stork came and delivered Emily to the front door, she could have inherited 1 of 3 different combinations of her parents' genes. 1 combination is 2 healthy genes. 1 possibility is being a carrier like Ma and Pa, and 1 combination would be affected with 2 unhealthy genes. This is like Emily. In summary, we all have 2 copies of every gene which are inherited from mom and dad. In the case of Emily, she inherited 2 copies of the non-functional gene which resulted in a non-functional protein and the disease. But there are 2 other case scenarios. One is that Emily is born a carrier like her parents. In this case, she can still produce the protein and is okay. Another scenario is that Emily is born with 2 healthy genes, and thus can produce the protein. So let's go back to the misconception. Do disease genes run in the family? No, there is no disease gene. There are only mutations in functional genes that could result in the disease. So maybe, before you believe mom's word is always gold, make sure to consider all the facts.